Today your warm-up is to attempt what you did 2 lessons ago of taking out GCF. So I want you to start with that. Take a minute, pause this, and then when you finish it, play it again so you can see the answers. All right, so hopefully you paused it and tried it. Your 2 answers should be 4 parentheses x squared minus 7. So this is the equivalent expression after taking out your GCF of the original problem. For the second one, you could have taken out x to the 4th, leaving you with 21x to the 5th plus 5 inside the parentheses. So if you had these correct, go ahead and fast forward to the lesson. If you need to see how these problems work, then stay on and I will explain these step by step. So looking at this first problem, 4x squared minus 28, the first thing we want to look at is to see if there's a number we can take out. So we're going to look at the 4 and the 28. The best way to do this is you always want to start by looking at the smallest coefficient. So I'm going to look, this term here has a 4 in front of it, which is definitely smaller than the 28. So we're just going to check and see if I can divide 28 by 4. Because if we can, then that's going to be our GCF. When you try that in a calculator, 28 divided by 4 gives you a whole number, it gives you 7. So we're going to use 4 as our GCF. The second thing we're going to look for is we have to see if we can take out any variables. This first term has an x squared on it, but this second term here doesn't have any x's at all. So since this one has no x's on it, we're not going to be able to take out a variable. So our GCF is just going to be, we're going to divide out the number 4. So that 4 goes to the front, and then I'm going to put parentheses. Inside the parentheses is what's left after we divide. So 4x squared divided by 4 is going to be 1x squared. So notice I just put an x squared here, but again, you all should hopefully remember that you can put the 1 there, it's just not necessary. Next, we have a negative 28 because a minus sign in front. So negative 28 divided by 4 is going to leave us with negative 7. So our equivalent expression after taking out a GCF is 4 times x squared minus 7. So that's your final answer. For the next problem, again, we're going to first look at the coefficients to see if there's a number we can divide out, then the variables. So again, we're always going to look at the smaller coefficient. So this smallest coefficient is 5. So we're going to see if I can divide 5 out of 21. When you type that in the calculator, it does give you a decimal, so it doesn't work. What I also know is 5 is prime. There's not a smaller number that goes into it other than 1. So we don't have a number that's a GCF. So now we're going to look and see, can we take out any variables? On the 21, this first term has x to the 9th. And the second term with the 5, we have x to the 4th. So I can take out variables, and we're always going to take out the variables with the smallest exponent. So our GCF here is going to be the fact that we can take out x to the 4th power. So we're going to put x to the 4th in the very front, and then again, we're just going to divide both terms by x to the 4th. Remember, there's technically a 1 in front of here, so if you want to put that there, you can. So 21 divided by 1 stays 21. And then x to the 9th, I'm dividing out x to the 4th. So remember, you're going to subtract the exponents. So that's going to leave us with 21x to the 5th. And then we have to do that again. So we look at this 5 and we're going to divide it by 1, which is going to stay 5. We had x to the 4th and we're taking x to the 4th out. So that means we're just going to have 5. So when you're all done with your GCF, you shouldn't have variables on every single term anymore. So this shows that we did take out the most x's that we could. So that is our final answer. All right, so factoring on day 6 is the same thing. We're going to use the star. However, we're going to put together what you guys saw on days 3 and 4, where there's actually a GCF to divide out first. So right now my trinomial is 2x squared minus 14x minus 36. So step 1 is to divide out a negative, but there's not a negative in the front, or to divide out any numbers or letters they all have in common. 2x squared, 14x, and 36, those all can be divided by the number 2. So I'm going to start this problem by dividing out their greatest common factor, which is 2. So just like we did with the -1, the 2 is going to go out front, and then I'm going to write in parentheses what's left. So 2x squared divided by 2 is 1x squared, or you can just write x squared. Negative 14x divided by 2 is negative 7x, and negative 36 divided by 2 is negative 18. So once you divide out a GCF, that stays in the front, and now A, B, C are the numbers that are left on the inside. So step 2, we're going to label A, B, and C and put them in the star. So A is 1, B is negative 7, and C is negative 18. So A times C goes on top, so my top number is negative 18. B goes on bottom, and then AX on either side. So we need to make our T-chart for the number 18 to fill in the rest of our star. So we have 1 and 18, 2 times 9, 3 times 6, 4 does not work, and neither does 5, and 6 is already on the list. So of these 3 pairs, I need to find one pair that will add or subtract to negative 7. So we're going to use 2 and 9, but to multiply to negative 18 and to add to negative 7, I know that the 9 has to be negative, because again, the bigger number will always match the sign on the bottom. So we're moving on to step 4, which is reducing the sides of the star. Here I have 1 over 2. I can't reduce 1 or 2. Same with 1 over negative 9. There's nothing that will reduce, and the negative is always going to stay on bottom. So now to write my final answer, step 5, we're going to start with our GCF. So I'm going to put 2 first, and then we're going to go with the sides of our stars. So the first side is 1x over 2, so that's x plus 2. And the other side is 1x over negative 9, so that's x minus 9. So again, when we factor, we're not solving, we're just writing it as an equivalent expression. So this is equivalent to the original problem we started with. All right, for our second example on day 6, we have the trinomial 3x to the 5th minus 5x to the 4th plus 2x to the 3rd. So again, step number 1, if a was negative, I would have to divide out a negative, but it's not. So now I just need to look, do all the terms have something in common? So can I divide 3, 5, and 2 by any number other than 1? And I can't. But what I do notice is I have x to the 5th, x to the 4th, and x to the 3rd. I always want this last term to have no variables at all. So the fact that I have x to the 3rd here, and these all have more than 3, an exponent of 3, here I'm able to divide out x to the 3rd. I can take out that many x's. So like before, we're going to do x to the 3rd in the front, and then within the parentheses, remember when you divide bases, you're going to subtract their exponents. So if I had x to the 5th and I take out x to the 3rd, that's going to leave me with 3x squared. I'm not touching the negative 5 at all, but x to the 4th divided by x to the 3rd would be x to the 1st, which is the same as just plain x. And then here I had the 2. If I had x to the 3rd and I'm dividing out x to the 3rd, there's no x's left on that last term. So now remember, a is always in front of x squared, b is always in front of x, and c is by itself. So now that I took out x to the 3rd, we see a, b, and c. So now we're going to go through this like normal. A is 3, b is negative 5, and c is 2. So we're going to write our star. 3 times 2 goes on top, which is 6. negative 5 is on bottom, and 3x on either side. So I'm actually going to go out to the side of the star and make my t-chart for 6 over here. So the only numbers that multiply to 6 are 1 and 6 and 2 and 3. 6 can be tricky because I can add or subtract to make 1 or 6 as negative 5. I could also use 2 and 3 to make negative 5 on bottom. So since my top number is positive 6, I know that my two numbers have to have the same sign. So they both have to be negative since there's a negative 5 on bottom. The only numbers that would work if they both have to be negative is negative 2 and negative 3. 1 and 6 would only work if I needed one negative number. So now that we're done with that, we're going to reduce the sides. I have 3x over negative 2, and nothing will reduce there. But on the other side, I have 3x and negative 3. So I clearly can take 3 out of both of these. So that's going to leave with 1x on top. And again, that negative stays, so it would be negative 1 on bottom. So those are going to be the sides that I use to create my factors. So last step is writing your final answer. We always start with the GCF. So I took out an x to the third at the very beginning of the problem. I have 3x over negative 2. So that's going to be 3x minus 2. And then I have 1x over negative 1. So that's just me x minus 1. So our final answer here, factoring with the GCF, is x cubed times 3x minus 2 times x minus 1.